In today's video, we will be diving deep into the intricacies of Wi-Fi technology, focusing on the MAC layer. If you ever wondered what goes behind the scenes when your devices are connected to the wireless network, you're at the right place. We will explore the sub-layers of layer 2, layer 1 in Wi-Fi, breaking down each element of a Wi-Fi frame, such as frame control, duration ID, different addresses. Whether you're a network novice or a seasoned professional, this video will clear understanding of the MAC layer on the Wi-Fi. So let's get started. MAC is an acronym for Medium Access Control. Now, as we know that Wi-Fi only exists on layer 1 and layer 2, something important to understand here is the layer 1 and layer 2 are also divided into two sub-layers. So layer 3 gives us the main data that is handed over to layer 2. Layer 2, if you look at it carefully, is further divided into two sub-layers, which is the LLC and the MAC. When the network layer sends data to data link layer, the data is handed off to the LLC and it becomes known as MAC Service Data Unit, which is MSDU. The 802.11 management and control frames do not carry upper layer information, the data frames do. And the 802.11/2020 standard states that the maximum size of MSDU can be 2304 bytes. It has three main parts: the MAC header, the frame body, and the frame check sequence. MAC header has the frame control information, duration information, which we will explore later. The frame body is the frame body component that can vary in size depending on the type of frame. Frame check is pretty much just think of that as an integrity check. Now let's get into the physical layer. The data link layer is divided into two sublayers. The upper portion is called the PLCP, and then the second portion is called the PMD. Now I know a lot of acronyms, but just hold on to see what they are doing. Picture is worth 1,000 words. So this is exactly explaining how that encapsulation is happening when the thing gets handed over from layer 3 to layer 2 to layer 1, and then on the other side it starts to decapsulate back. So if you can keep this picture in your mind when you're understanding how the things get handed over, this will actually help you a lot. Now let's look into a little more detail. So MSDU, MAC Service Data Unit, this is, as I said before, is what gets handed over from layer 3. This is the application creating the actual data, and it's given to the LLC. Once it's given to the LLC, it will pass it to the MAC layer. This is where it becomes the MPDU, which is MAC Protocol Data Unit. It's received by the LLC. It adds the MAC header at this point. It's passed on to the PLCP, which is the first layer of the physical layer. This is where the preamble and the physical header are added or removed at the PLCP layer. Now it's passed on to the PMD layer. The PMD sublayer takes the PPDU and modulates the data bits and begins transmitting at this point. So this is where everything gets converted into zeros and ones, and we go ahead and actually transmit it. Okay, so that is done by the last layer. And from here on, it is passed on to the RF, and it's received by the other end, and the same process happens in reverse on the receiver end now. So this, what we saw, was on the transmitter end. Now let's look at different type of addresses. Individual addresses are one-to-one, which means I'm sending to a specific person at this point or receiving from a specific person. These are unicast addresses. Addresses would be multicast or broadcast, which means I'm sending to a particular group. Broadcast means getting it to everyone at this point. Multicast, think of as for somebody who's only subscribed to get a specific kind of frames. So that is the difference between your multicast and broadcast, but they're all group addresses at this point. Now let's look at a full 802.11 MAC header. Now MAC header addressing used by 802.11 frames is much more complex than Ethernet frames. 802.11.3 frames only have a source address and a destination in layer 2 header. Wherever, if you see here, you see 4 of them. Now this picture I took from the Security Tube website, I guess it was. But what's interesting in this picture is they're actually showing you each and every byte size of each part of that frame. It's a big frame. If you look at the frame control itself is 2 bytes, duration ID is 2 bytes, addresses each are 6 bytes, and so on. And the frame body, as you see, it could be up to 23124. As we said, in wireless, we could have more than 2. We have source and destination, same like Ethernet, but we also have the transmitter address, the receiver address. Only other thing you will see here is also a basic service set identifier, which really means is if I am an access point having multiple SSIDs, which radio is going to be used for that specific SSID. That's why I should know that, okay, which access point am I connecting to at this point? That's why I need the BSS ID. The rest are pretty much simple to understand: sources, who's sending, destination, who's receiving, transmitter, who's again transmitting, and so on, right? So that makes a lot of sense. So again, 4 types of addresses: the receiver address, the transmitter address, the destination address, and the source address. This is what we're going to be looking into when we look into how these 4 gets used. So let's get into how they get used, especially when you're transmitting or you're receiving. Let's look into that next. Before we get there, if you look at the frame control, which is just 2 bytes, but in itself, it's such a monster of a frame, like monster of information in there. Let's look at each one of them one by one. The protocol type, the type, subtype, 2DS. So what does each of this really mean? This is very important to understand. This kind of tells you where the frame is going. Is it a retry frame? What are these really things? Is it protected? So it has a lot of information that is very helpful when you're trying to understand a particular frame. So let's start with the first thing, which is the protocol. When a major revision comes, that's when it's going to get to 1, and that really means is I'm not backward compatible. At this point, any frame you capture will always have a value 0, which means we so far have been developing Wi-Fi that is always backward compatible. So that is something important to understand, and you'll always see it's 0. Type, subtype really means what type of frame of this? Is it a management frame? Is it a control frame? Is it a data frame? And what subtype of that management frame? Is it a beacon frame? Is it a probe request, probe response? So just to give you an idea of all these frames, in general, Wi-Fi has 3 types of frames: management, control, and data, as I mentioned. And if you look at, they have subtypes. So this slide gives you more of what those are. I'm not going to go into them right now, since we will look at in the further videos that I'm going to create. So, but you see that there is a whole bunch of management frames, whole bunch of control frames, and then obviously data frame is just the frame that carries the actual data. DS really means distribution system. So 2DS from DS actually helps us understand, is the frame management or a control frame, or is it going up or down? So 00 is mainly used for management and control frames. 01 is when data is sent downlink from the AP to client. 10 is used when you're using data sent up from a client. 11 is used only when you're using a wireless bridge. So let's look at this example right here. 10, which means 2DS is 1, which means I'm going towards the distribution system in this case. So it's going up from the client. Now how the addresses come on. If you look at this now, the first thing is the receiver address. Who's going to receive it? Obviously the AP BSS ID. So that's the receiver address. Who's sending it? Who's transmitting? It's the client at this point. Who's the final destination? That's the gateway. And the third one or the fourth one is not used because it's already set up in the second. So let's look at another example here now. Is 01, which means it is coming from the DS. It's coming from the distribution system towards the client. That's how I know that the frame is downlink from AP to the client. The address client, sender is going to be the APBS ID, destination is not used because it's the same, and so on, right? So now this is the only case where you'll end up using all 4, right? This is where it is 1-1 from DS to DS are 1-1 at this point, because it's a wireless bridge that we're going to be using in this case. So just remember, when you're sending from a client up to an AP or an AP is sending down, it will use 3 addresses. The only time that we end up using all the 4 addresses is going to be when you have a wireless bridge. And this is the case. And we will look into each an example when it's going from a client to the actual distribution system and also back from distribution system to client to see how does that work. So again, only thing to remember, 4 addresses only in case of wireless bridge. Otherwise, we end up using 3. Okay, so not 4 gets used all the time. Very important concept to remember. Now the first we'll look at if the client is trying to send to the distribution system. So the receiver address will be the root bridge SSID. Transmitter would be the non-root. So these are the 2 transmitting. Destination is obviously the gateway, which is the distribution system, and the source is the client. So again, you saw none of them got repeated. Everybody has been used in each field. So all 4 addresses at this point got used. Now let's look at the reverse. If the packet was coming from the distribution system to the client, receiver address will be the non-root bridge. Sending, root, destination, client, sender, gateway. All 4 got used again. Let's get back to the frame again. This is just saying that if the frame is fragmented or no. That means, is it being broken down into further smaller, or yes or no? Retry, Wi-Fi, another very important concept. Each packet that is sent has to be acknowledged back. If it's not acknowledged, you have to retry it. It's almost like me trying to talk to somebody. If I'm not sure if he heard or she heard to me or no, I'll have to say the same thing I said before again. That's a retry. So if I see a frame, it's one, that means it's a retry. If you have more retries, that means your network is not performing very well. Power management is in place for the stations or the end devices so that they can go off to sleep. This is to conserve their energy. And it has two modes. It's the power save mode or the active mode. Power save means when it's dozing. Active mode means when it's up and listening to all the frames that the APR is sending at this point. More data means if I have more data, which is also part of the power save, which we'll look into in the further few slides, I guess I have. Now, the next thing I want to look at, if you look at the frame, is the protected frame. Now, protected frame really means is my frame protected? Is the stuff that I'm sending, is it encrypted or not? So only when it is set to 1, that means if somebody's listening to me, it will be encrypted. If it's 0, which means it is not encrypted at all, means anybody who's able to capture that frame wirelessly is able to read stuff and see what's going on. But that doesn't mean it's not encrypted on the higher layer. So if you're using HTTPS, it could be encrypted at the higher level still. So don't get confused with that part, okay? That if it's not protected means everything is open. It's still not open. So it could be that it's encrypted by a higher layer at this point. Again, a very important concept to remember and keep that in mind. Last but not the least, from a frame control perspective, other indicates if all the frames obviously they have received, they have to come in order. If I'm sending something, the message has to be in a certain order. It cannot be out of order because then it won't make sense onto the receiving party at this point. That is all for the frame control. Now, duration IDs just means that how long does it take for this frame to transmit. Now, why do I do that in Wi-Fi? Now, think about this. Wi-Fi is a half duplex system where one person talks at a time. I want to make sure that it doesn't collide with other frames, which really means is it's not going to really collide. It really means is if two frames come at the same time, the person who's receiving it won't be able to understand what's happening. It's almost like two people talking same time. The third person has no clue what they're talking. Okay, so they're kind of talking over each other. So we want to avoid that in Wi-Fi. So duration ID really means I'm going to be talking for the next 10 minutes. That means all the people in the room at this point know that this guy is going to be talking for 10 minutes. So we have to all be quiet for 10 minutes. Then we have the addresses that we already kind of looked at, which are 4 in Wi-Fi. We saw what they are and how the use cases are while going up or coming down. Only thing to remember again, I'll say is 3 of them get used when you're sending normal data and 4 of them used when you're sending a bridge. Now let's look at the sequence control. Again, trying to control the sequence number here. So that's basically what they are in a fragment packet. So what's if I've broken a packet into small parts, which goes first, which comes second, which comes third, and so on, right? So that pretty much is the requirement or the need of the sequence control part in this frame. Next, we'll look into the QS control, which is mainly for the data, which means quality of service at that point. Now, quality of service is a little different in Wi-Fi, which we'll talk about in the future. It's more based on probability. It's not fixed at that point. It's not that there's a good chance that I will be able to send a certain data. Now, why do I need quality of service? It's when I have congestion, I want to make sure that certain traffic, which is more important, gets prioritized than the others. So browsing, sure, if it spins a little bit, it's going to be fine. But if I'm trying to use a voice packet, I want to make sure that reaches on time, because if there's a delay in a voice stream or a video stream, it will start to break. Okay, so that covers that. Now, this is the frame body. Management will not have much here, but the actual data is what comes. So this is what the application has created. And this is the MSDU that has been sent down from the layer 3 and passed on to the LLC layer that we looked at the beginning of this video. So this is the real data, okay? Now, last part of this is the FCS, which is the frame check, right? So which is the CRC check also called as, which is really there for making sure the integrity of the frame has not been touched. So the way the frame was sent, it is intact. Nobody hampered your frame. It's still in good shape. that wraps up our in-depth look at the Mac layer in Wi-Fi. We've covered essentials, sublayers, and dissected the key components of a Wi-Fi frame, from frame control to addresses. And we also covered different frame types and few more details. Now, understanding these elements is crucial for anyone who's looking to master wireless networking. I hope you found this video useful. Until next time.